All right, guys, now we're getting to composition of functions. So this is a little more interesting. We just discussed talking about adding and subtracting, multiplying, dividing, polynomials, and other functions. Now we're going to compose them. All right, so what that means is we're going to take, this is our notation right here. If we have functions f and g, if we compose them, this is f composed of g of x. So that means what we're doing, we're taking f. And inside of f, we're sticking g of x. That's all we're doing. We're plugging in a function into another function. Okay, let's look at an example because you're like, what? So here's our two functions. Well, we got three of them. And it's asking f composed of g. So that means we're going to take g and stick it into f. Now, I know we're always supposed to, go left to right because we're in America and whatnot. Composition of functions, you can be Chinese. You go right to left. Pretend you're reading a manga. So you stick x into g and stick that into f. So let's see, g of x right here is going to f of x right here. So what I like to do, I take f, that's what I'm plugging it into. I write it down, except instead of x, I put some big old parentheses. What's going in there? Who cares? Anytime I have an x, I'm going to replace it with a big set of parentheses. Now I'm going to go back. What am I sticking inside of f? I'm shoving g of x down its throat. G of x is x minus 1. Oh, lovely. So we have x minus 1 to the third power plus 8. This will be on another page. So, do what you got to do. For those of you that like Pascal's triangle, you can use that. For those of you who have no idea what I'm talking about, don't worry about it. Just multiply. Just as a side note, for those of you curious, you might know Pascal's triangle. If you don't, you should probably look it up. It's a very nice thing. But since we're going to cube something, it's going to have these coefficients. Watch what happens. 1, 3, 3, 1. Watch. Okay, so that's going to be 2 at a time. X squared minus x. Then we have negative x plus 1. Don't forget that plus 8 hanging out on the side. All right, combine my like terms. All right, then we take this guy, distribute it to everybody, this guy, distribute it, this guy, distribute it. Let's do it. Plus 8, sorry. X cubed minus x squared minus 2x squared plus 2x plus x minus 1. Let's plus 8 over here. Now, first off, I'm going to combine these like terms so you can see something real quick that's pretty nifty. It's going to be x cubed minus 3x squared plus 3x minus 1. Haha, I told you. 1, 3, 3, 1. That's the coefficients. So Pascal's triangle, if you're raising a binomial to a power, these are going to be your coefficients. Like this is not going to be on the test or anything. So if you're raising it to the third power, it's going to be 1 times a cubed. You reduce the power by a, power of a by 1, plus 3a squared b. And then you reduce the power of a again, plus 3ab squared plus 1b cubed. Your total power is always going to be 3 on these. You're just going to start with the a and reduce it by 1 each time. And that's why it's alternating positive and negative, because it was x minus 1. So anytime you had a b squared, it's going to be positive. These two would be negative. And if you're going to do the fourth term, it will be right there. So this is completely off topic, but hey, it's interesting. Now, how you make it is you start with your 1s, then your 1, 1, and then you form your triangle from, you start with the 1, these two make this one 1. Start with the 1, these two, 1. 1, these two, 1. 1, 5, 10, 10, 5, 1. And that's, this is the second power, third, fourth, fifth. And that's just, you can quickly raise the binomial to any power with this little triangle. Might be a mystical tip for the ACT sometime in the future. I don't know, might not be, but it's fun. So I also have this plus 8 over here. I'm just going to go ahead and stick that on there. That's going to become, so minus 1 plus 7. So, yeah, I don't know, I have to delete that. Might not. Not today's, I'm not going to delete it. But the main thing is we took g of x right here and plugged into f. That's all we did. That's what composition means. So let me copy this on another page because I have no space here. And if that whole binomial Pascal's triangle thing confused you, just ignore it, and let's try number 12. H of g of x. So that means x is going into g right here, and this thing is going into h. Here's h. So 5 somethings minus 3. That something happens to be g, x minus 1. Distribute 5x minus 5 minus 3. Combine like terms, 5x minus 8. All right. So we're just plugging these into each other. Order matters. H of g is not the same as g of h, so I don't think it is. See what the next one is. F of h. Let's check it out. That's going to be another fun one. I'm going to skip the whole Pascal's triangle thing for those of you that got thoroughly confused on the first one. Sorry. So I'm taking h. I'm going to plug it into f. So let's look at f. Something, the third power, plus 8. That something is going to be f, or actually it's h. 5x minus 3. So we're going to multiply this times itself 3 times. Well, total 3 times factors there. So 5x times 5x, I'm just going to do these two first. 25x squared. 5x times negative 3, negative 15x. Negative 15x plus 9. This is going to be times 5x minus 3, but I definitely want to combine like terms first. Don't forget that little plus 8 hanging out to the side. So I'm going to take a time, combine my like terms. All right. Distribute again. I have a trinomial times a binomial now. That's going to be 125 x to the third power. Then that's minus 75x squared. And that's negative 30, so that's negative 150x squared. Plus 90x. Plus 45x. Minus 27. And then I have that plus 8 just hanging out there still. Combine your like terms, and we got 125x cubes. Negative 225 x squared plus 135 so plus 135x minus 19. And that's all we got. That's f of h of x. So we're just evaluating these functions. Just add a function. We'll be multiplying, adding, subtracting. Nothing new. Just have to do them all at once. All right, let's check out g of f of x. So that means I'm going to plug f into g this time. I'll start with g. Big old parentheses where I got an x. Got an x there, minus 1. What's going inside of those parentheses? F is this guy. Oh, well, I'm not doing anything to it, so it's just that. Completely and totally different from f of g, right? On that one, we got this crazy cubic right here. It's got an x squared term, an x term. Over here, we just got x cubed plus 7. You can even know what that looks like. That's their standard little cubic mother function. Oh no, numbers. Well, that makes it easier actually. So here we go. Same exact thing. We pretend you're reading a manga, right to left. So I'm going to take 2 and plug it into h. Oh, so I need h of 2. Now you could do it the same way as before. Plug in the h of x into g of x, and then simplify and all that good stuff, and then plug in the 2. Guess what? It's not easy. So that's 5 times 2 minus 3. Well, that's 7. Now we take our answer and plug it into g. So that's going to be 7 minus 1, which is 6. That's it. That's all you got to do. H of f of negative 6. Negative 6 is going into f. So it's negative 6 cubed plus 8. So that's negative 216 plus 8, which is negative 208. Of course, if you're on the calculator, you can do parentheses, negative 6 raised to the third power plus 8, and there you go. So that's a little any exponent button right there. And that's all composition is, people. You're just plugging functions into functions. So for now, that's it. We're done. Well,